Hi everyone. Today we're going to study derivative of a function at a given point. We understand that the derivative of the function f of x, denoted by f prime of x, is defined to be f prime of x equals the limit of f of x plus h minus f of x all over h as h approaches 0. Now, the derivative of a function f of x at the specific point x equals a is f prime of a, and the formula is the limit of f of a plus h minus f of a all over h as h approaches 0. Here are the steps to find derivative of a function at a given point. Step 1. Solve for f of a plus h. Step 2. Solve for f of a. Step 3. Evaluate f prime of a using the limit formula. And this is the formula. Note that the steps 1 and 2 are the values needed in the numerator of this formula. Example 1. Use the definition to find the derivative of f of x equals x squared plus 9x at x equals 2. Step 1. Solve for f of a plus h. The value of x here is 2. That is our a. So, a equals 2. That means in step 1, we need to evaluate f of 2 plus h. Consider our function here. We're going to change all the x on the right side by 2 plus h. So we have now the square of 2 plus h plus 9 times the quantity 2 plus h. We expand this square of binomial, so it will be 4 plus 4h plus h squared. Then 9 times 2 is 18, 9 times h is 9h. We can combine like terms. 4 plus 18 will be 22, 4h plus 9h is positive 13h plus the h squared. Then we go to step 2. And that is, we solve for f of a. That means, let's evaluate f of 2. Consider our function here. We change x on the right side as the value 2. So we have 2 squared plus 9 times 2. Simplifying further, we have 4 plus 18, and that will be 22. This is our value for f of 2. Now step 3. We evaluate f prime of a. That means f prime of 2. And we have this formula. Remember that the values of step 1 and step 2 are the values needed in the numerator. Substituting the corresponding values, we have now the limit of 22 plus 13h plus h squared minus 22 all over h as h approaches 0. We can remove the grouping symbols respectively. So we have like this. Let us combine 22 by negative 22. That will be 0. So in the numerator, the values are 13h plus h squared. Then notice that h is common to the two terms of numerator. We can factor it out. Numerator becomes h times the quantity 13 plus h. Now the h in the numerator can be cancelled with the h in the denominator. So we simplify further this expression as the limit of 13 plus h as h approaches 0. Let us now evaluate the limit, meaning we change this h by 0. So we have 13 plus 0, and the answer is 13. This is the final answer. Example 2. Use the definition to find the derivative of f of x equals the square root of the quantity x minus 2 at x equals 4. Note that the value of a here is 4. So for step 1, we need to evaluate f of 4 plus h. Consider our function here. We're going to change this x by 4 plus h. So we have the square root of the quantity 4 plus h, then the minus 2. We can remove the grouping symbol, and then we combine 4 minus 2. So we have now the square root of 2 plus h. Then step 2. Let's evaluate f of 4. Consider the given function here. Let us change x by 4. So we have the square root of 4 minus 2. So we can simplify this as square root of 2. Then we go to step 3, f prime of 4 using this big formula. Again, we remember that the values of step 1 and step 2 are needed in our numerator. So we have the square root of 2 plus h minus the square root of 2 all over h. We will take the limit as h approaches 0. In the numerator, we cannot simplify further the radicals. We cannot cancel anything here. And suppose we want to evaluate the limit, meaning we substitute 0 to the h. Imagine that the values will come to 0 over 0, which is what we call an indeterminate form. So we will go to the next method. Since we have radicals, we are going to use the conjugate method. So we rewrite the problem in here. Let us now multiply the numerator by its conjugate. So that will be the square root of 2 plus h. This is minus, so we write here plus. And then the square root of 2. And for the denominator here, we will just copy the numerator. Now let us simplify further. Let us multiply the fractions. Numerator times numerator, denominator times denominator. In the numerator, we apply our special product. So we have the square of the quantity, square root of 2 plus h, minus the square root of 2, all over. In the denominator, we just put together the two values. So we have the h times this group. We will take the limit later. In the numerator, we can cancel the radical and the corresponding power. So we have like this. And we rewrite the numerator as 2 plus h minus 2. We can see that we can combine these 2 and minus 2. That would be 0. So in the numerator, what remains is h alone. This h and the h in the denominator, we can cancel out. So we simplify further as 1 all over the square root of 2 plus h plus the square root of 2. From here, we will apply the limit. We will change h by 0. So it becomes 1 all over the square root of 2 plus 0 plus the square root of 2. Where we simplify this expression here as simply square root of 2. We combine square root of 2 plus square root of 2, and that will be 2 square root of 2. The numerator is 1. This is the final answer.